This lecture is on accuracy versus precision. Accuracy refers to how close a particular measurement is to its actual or true value. For example, the density of aluminum is 2.70 grams per cubic centimeter. Suppose you have three students who did determine the density of an aluminum rod. Which one was the most accurate? Student A is 2.71 G per cubic cm. Student B is 2.86 G per cubic cm. Student C is 2.54 G per cubic cm. The answer is student A, because the difference between the experimental and actual value is smallest and closest to zero. Determining the accuracy of a measurement can be done by the following equations. Percent error equals the absolute value of the difference between the measured value and true value divided by the true value times 100%. Absolute error is the absolute value for the difference between the measured value and true value. Precision refers to how close two or more values or measurements are to each other in a set. Suppose you have two students who have to weigh a piece of wood 3 times on a top-loading balance. Student A has 3 trials weighing for unknown 35 and recorded the following measurements: 10.53 G, 10.55 G, and 10.52 G. Student B has 3 trials weighing for unknown 12 and recorded the following measurements: 6.25 G, 5.65 G, and 6.85 G. Which student has the more precise data set? Answer is student A, because the range in values is much smaller than student B. Student A has a range difference of 0.03 grams, whereas student B has a range difference of 1.20 grams. Determining the precision of a measurement can be done by the following statistical calculations. 1. Range is the difference between the high value and low value in a data set. 2. Percent deviation is the difference between the experimental value and average value divided by the average value times 100%. 3. Standard deviation is S equals the square root of the sum of the difference between xi minus the mean of the data set squared divided by n minus 1. 4. Percent standard deviation, or percent RSD, relative standard deviation, equals standard deviation divided by the average or mean times 100%. This figure here is a Gaussian or normal distribution curve that tells what portion of the values fall within the mean and a specific number of standard deviations. It is in a bell-shaped curve. 68% of the values fall within the mean plus or minus 1 standard deviation. 90% of the values fall within the mean plus or minus 2 standard deviations. 99.7% of the values fall within the mean plus or minus 3 standard deviations. Here are the illustrations of the 4 different possible outcomes with accuracy and precision. The first bullseye dartboard has all 3 darts at the center of the target, so it is described as good accuracy and good precision. The second bullseye dartboard has all 3 darts scattered all over the bullseye, so it is described as poor accuracy and poor precision. The third bullseye dartboard has all 3 darts at the lower bottom of the target, so it is described as poor accuracy and good precision. The fourth bullseye dartboard has all 3 darts at the outer right wing, but scattered, so it is described as good accuracy and poor precision. Systematic errors are errors that deals having the same amount of difference in measurement in the same direction. Errors of this nature can be fixed and corrected. Random errors are errors that can be, after repeated attempts, can have results that are either positive or negative off the true value. These errors cannot be eliminated, so only by using more precise devices can minimize these errors. Here is a review exercise for you to work on. Case study 1 is, a student does 3 measurements for determining the mass of an unknown solid. Readings 1 to 3 are 5.85 G, 5.95 G, and 5.92 G. True value is 5.91 G. Case study 2 is, a student performs doing the density of copper from 3 measured values. Readings 1 to 3 are 8.35 G per cc, 8.30 G per cc, and 8.31 G per cc. True value is 8.73 G per cc. Discuss the precision and accuracy of each case. For the main part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.